Hi everyone! In this video, we're going to learn about angles. We'll talk about how to measure angles and what types of angles there are. So angle is obtained by taking one ray, which we call initial side of the angle, and rotating another ray, which is the terminal side of the angle. As you can see, these rays have the common endpoint, which is the vertex of the angle. Angles are measured by the amount of rotation that took place. And the most common unit for measuring angles is the degree. You can probably recognize that this angle measures 90 degrees, which we also call right angle. And a common notation for the right angle is to put a little square at its vertex. So let's look at a few other interesting angles. So what you're looking at here is a 0-degree angle. Well, it has initial side and terminal side, but there's no rotation that happened. So the initial side and terminal side coincide. So it's 0-degree angle. Next, let's look at the angle that we rotate in such way that its terminal side and initial side form a straight line. That's where the name of this angle comes from. It's called straight angle, and it measures 180 degrees. And how about an angle that we obtain by rotating the terminal side until it comes back to the initial side? In other words, it makes a full circle. Well, that angle measures 360 degrees. So one full rotation, one circle, is 360 degrees. And there are different theories why it's 360 and not any other number. Some of them say that, well, it's just a very convenient number. It's divisible by a lot of other numbers, 360. And it also close to the number of days in a year. Well, let's move on. Now we're going to look at different types of angles. And first, let's learn or refresh the difference between acute angle and obtuse angle. So acute angle is the one that measures between 0 degrees and 90 degrees. And obtuse angle is the one that measures between 90 and 180 degrees. Acute versus obtuse. Next, let's talk about complementary angles and supplementary angles. So both types of angles come in pairs. So complementary angles, these are two angles such that the sum of their measures is 90 degrees. And two angles are called supplementary if the sum of their measures is 180 degrees. And I have to make a note here that only positive angles can be called complementary or supplementary. Now, it's very common to confuse those two groups of angles, and this is how I keep them straight. So if I put their names, complementary, supplementary, in alphabetical order, so complementary first, since it starts with C, and then supplementary, then I also have to put their sums in order. So 90 and then 180. So that's how I remember that. Just my little trick that I use. Now let's try an example. It says that we need to find the measure of the supplement of an angle measuring 70 degrees. So the key word is the supplement. That means that we have to find an angle such that that angle and 70-degree angle are supplementary angles. In other words, their sum is 180. Well, to find the unknown angle, we have to take 180 degrees and subtract 70, the given angle. That is 110 degrees. So the supplement of an angle measuring 70 degrees is 110-degree angle. Now, if the first example made sense, we should have no problem doing the second example. Here we need to find the measure of the complement of an angle. So that's the key word. And if I'm doing it without any notes, then I'll remember that since it starts with C, which comes before S for supplement, then I have to go with 90 degrees. In other words, complementary angles add up to 90. Well, if one of them is 70, what's the other one? I'm going to take 90 degrees and subtract 70. I'll get 20 degrees. So 20-degree angle and 70-degree angle are the complements. I don't know if you've noticed, but all angles that we've looked at so far were rotated counterclockwise. But can we rotate angles clockwise? Well, yes, we can. And let's talk about the difference. So once again, we can rotate angles counterclockwise, or we can rotate angles clockwise, this way. And the difference is the following. When we rotate counterclockwise, we obtain positive angles. We already know that this is 90-degree angle, well, positive 90-degree angle. But when we rotate clockwise, we obtain negative angles. As you can see, the amount of rotation is the same as in the first place. The only difference is the direction. For this reason, the angle that we obtained measures negative 90 degrees. So once again, counterclockwise rotation produces positive angles. Clockwise rotation produces negative angles. Next, let's talk about angles in standard position. For that, we're gonna place the angle that we see on the screen right now on the XY plane. Remember, the horizontal axis, the x-axis, the vertical y-axis. So the way we positioned the given angle in XY plane is such that its initial side lies on the positive x-axis and the vertex of the angle is at the origin. So let's refresh a few things about XY plane. The x and y axis split the entire plane, the region, into 4 quadrants. And most likely you already came across those quadrants in different math courses. And I don't know if you ever wondered why quadrants are numbered in counterclockwise direction. Well, now as we learned about angles in standard position, we can see that the order in which quadrants are numbered corresponds to the direction in which we rotate positive angles. And now as we put things together, we can say that different angles terminate at different quadrants. Let's just do an example. Let's say I want to sketch an angle in standard position that measures 200 degrees. Well, this means that I have to place the initial side of the angle on the positive side of the x-axis and then rotate it in counterclockwise direction 200 degrees. Well, I know that if I get this far, it's going to be 90. If I get this far, it's going to be 180. And I need a little bit more, right? I need 20 degrees more. So let's say up to here. So that's where a 200-degree angle should terminate. And here it's terminal side, so 200 degrees. And what I can say about 200-degree angle is that it terminates in quadrant 3. So we say angle terminates at the quadrant where its terminal side is. And of course, we know that there are angles that terminate not in the quadrant, but right on the axis. For example, 90-degree angle will terminate right here on the positive y-axis. 270-degree angle will terminate here on the negative y-axis. And those angles, and these types of angles are called quadrantal angles. Here's the next question. Can angles measure more than 360 degrees? Remember, 360 degrees is a full circle. Well, the answer to this question is yes. Angles can measure more than 360 degrees. Let's look at an angle like that. I'm going to work with an angle in standard position, so that's why I have XY plane here. And this is what I'm going to do. Here's the initial side of the angle. And now I'm going to start rotating. So first I'm going to make a full circle, full rotation. So I just got back to the initial side, which means that I just traveled 360 degrees. But guess what? I'm not going to stop here. I'm going to keep rotating. I'm going to keep rotating, and I'm going to make another full circle. So where am I right now? Well, I initially rotated 360 degrees, and then I made another full circle, so it's another 360 degrees. And I think I'm going to rotate a little bit more. I'm going to go up to here, and that's where I'm going to stop. So that's where the terminal side of my angle is going to be. So what is the measure of this angle? Well, be careful here. Even though it looks like 90-degree angle, it's not, Because remember, the measure of the angle is the amount of rotation. So obviously we rotated here more than just 90. And we already said how we rotated the first full circle, that was 360. And then we rotated another full circle, so that's another 360. I have to add that. And then we rotated a little bit more. Well, that a little bit more was 90 degrees. Remember, this portion, that remaining portion, that is 90. So that's plus 90. And then when I add those numbers up, well, then I'll find out the measure of this angle. So 0, then 12 plus 9, 21. And then 3 plus 3, 6, 6 plus 2, 8. So this angle actually measures 810 degrees. And now you probably got the idea that we can this way obtain how many other angles? Well, infinitely many, right? We can keep rotating and rotating and rotating and obtaining more and more angles. By the way, we can do this continuous rotation in both directions, counterclockwise. That's how we obtain positive angles. Notice 810 is positive, right? And if I did similar thing but in clockwise direction, I would obtain a negative angle. But let's go back to the fact that this angle terminates at the same place as the 90-degree angle terminates. So if I ignore that red spiral, well, it looks like 90-degree angle, right? Well, our angle, 810-degree angle, is related to 90-degree angle. They're called coterminal angles. So coterminal angles are the ones that have same initial and terminal sides. However, they have different amounts of rotation. So let's play with coterminal angles a little bit more. We're going to do a few examples. So let's pick an angle. Let's say angle that measures 110 degrees. So I'm going to place its initial side at the positive x-axis, then 110. How far do I rotate? I'll have to go up to 90. I'm not there yet, right? So I have to rotate, what, 20 degrees more? So here it is. And now I want to obtain an angle that's coterminal with my angle. So I know it has to have the same initial side and then same terminal side. So I'm gonna start here as well, but I'm not gonna stop here, right? Because that's the same angle, 110. I'm gonna keep rotating. So now I'm at 360, but I'll keep going because remember I have to reach same terminal side. So I'll go all the way to here. So what I just showed in red is the angle that has same initial side and same terminal side. So it's going to be coterminal with my original angle, 110 degrees. But what is the angle measure of the one I just showed? Well, let's count. It's, remember how we did one full circle, so it's 360. And then I traveled 110 degrees more. So it's plus 110. So 0.74. 470 degrees. So the one that I showed in red is 470 degrees, and it's a positive angle, obviously, right? I rotated in a counterclockwise direction. And now I can say that 110 degree and 470 degree angles are coterminal. Here's the question, can I find another coterminal angle? And let's make it even more interesting. Can I find a negative coterminal angle? Well, you probably know the answer to this question. Yes, I can, right? I'm going to show it here on the right. Since I'm specifically looking for a negative angle, it means that I have to start at the same initial side, but rotate clockwise. I'm going clockwise until I hit that terminal side. Remember, they have to have same terminal side. Okay, well, it is a negative angle because I was rotating clockwise, but what is the measure of that negative angle? Let's count. So I know that going from the initial side this far is negative 180. Then how much more I need to add? Let's figure it out. So I'm going to go back to the original angle. I know it's 110, right? Since it's 110, I know that here I have 20 degrees, right? So it's 90 plus 20 gives me 110. Well, if that is 20 degrees and one quadrant, the entire quadrant is 90, that means that this remaining portion should be 70 degrees, right? Because together 70 and 20 make 90 degrees, which is one quadrant. Now, if that's 70, then what are we going to get? So first we went negative 180, and then we continued going 70 more, right? 70 degrees more in clockwise direction, so it's another 70 degrees. So altogether it's going to be 0, 5, 2, 250. Okay, so this negative angle measures negative 250 degrees. So I could say that 110 degree and negative 250 degree angles are coterminal. So that is the idea about coterminal angles. Well, could I find more coterminal angles with the angle 110 degrees? Yes, if I didn't stop here but made another full circle and then stopped, so it's another 360 in clockwise direction, well, that would be also coterminal. And then I can add as many full rotations as I want, and every time I would end up with a coterminal angle with 110 degree angle, right? And then same idea for positive coterminal angles. Remember, we did full rotation 360 and then 110. Well, I could do more than one full rotation, 1, 2, and then 110. And now look at that. Well, if I take 110 and add 360, I get 470, which is coterminal angle, right? We already figured it out. And if I keep adding 360, I will be getting more and more coterminal angles. Or if I take 110 and subtract 360, I'm gonna get negative 250, which is coterminal angle. We already figured it out. But then I can keep subtracting 360 again and again and getting more and more coterminal angles. So, long story short, measures of coterminal angles differ by a multiple of 360. Multiple means that, well, you can add or subtract 360 so many times, 1 time, 2 times, 3 times, and every time you do that, you're going to obtain a coterminal angle. So that's the way to find coterminal angles algebraically, by just purely doing calculation, or it's also a fun exercise to figure them out by drawing the angles. Either way, you get the same answer. And that concludes our introduction video about angles.